Good morning, everyone. Good morning. Good morning and welcome to the industry breakfast. I hope you are enjoying your morning so far. How are you all this morning? Hello? Good? Okay, that's good. And for those students watching the live stream, welcome to the event. My name is Maria Parapilli and I am a professor of physics at Flinders University, and I also lead the international student recruitment for the College of Science and Engineering. Before getting into the formal proceedings, I would like to begin by acknowledging that we are meeting on the traditional country of Ghana people of the Adelaide Plains, and I would like to pay my respects to the elders, past, present, and emerging. First, let me go through some housekeeping matters. Please note that Wi-Fi will be available throughout the breakfast, so you all will be fine, okay? And the toilets are located on the sides of this venue, and you can't miss the signage, all right? At this stage, I would like to invite Professor Sophie Leterme, the director of the ARC Center for Industry Transformation Training Center on Biofilm Research and Innovation from the College of Science and Engineering, for the official opening address. And Sophie is a research leader, and you will be able to hear more from her. Thank you.
Good morning, everyone, and welcome to Flinders University. Welcome to our College of Science and Engineering, and welcome to this industry breakfast. It's fantastic to see so many people here this morning. I would like to begin by acknowledging that today the Kaurna people, the traditional custodian of the land on which we are meeting, and paying my respect to their elder past and present and emerging. I would like also to thank our industry partners and visitors today for making an early start with Flinders, and we deeply appreciate your support this morning and your presence here. Flinders University is on the move. We have a lot of things that are being developed and are very excited. Coming up, you might have seen on Flinders University Avenue on your way here this morning, the new Health and Medical Research Building, which has been an investment of around 250 million in medical research. We are expecting this building to be ready soon, and it's so exciting to have such a facility on campus. You might also have heard that we have a new facility in the city next to the train station, where we're going to be able to start delivering courses from February 2024. And finally, I wanted to mention our Factory of the Future at Tonsley, which is a venture that allows scientists, but also students and industry to come together and look at the future of industry and novel technology. If I go back to the College of Science and Engineering, at our level, we are completing a lot of new research facilities and teaching facilities that will be ready this year. We have a new first-year lab for chemistry, which will be completed in 2023 for an investment of 4.5 million. A new chemistry laboratory with 22 fume hoods. Lots of amazing reactions will be done there. That will open in July 2023 for the second semester. A new student area and library has been opened at Tonsley to facilitate our students based at Tonsley to access those resources. And we have also a new greenhouse that is being built and finalized with PC2 requirements here on campus. All of this allowing our students to grow and develop a lot of new skills in different areas. Less visible, but also important, is the rollout of new courses that are available now at Flinders. We have a Bachelor of IT in Digital Forensic, a Bachelor of Engineering and Technology with Advanced Manufacturing and Digital Design, and a Bachelor of Science in Plant Science. For those of you from industry, at the college we pride ourselves in producing student engineers and scientists, not engineering and scientist students. A key component of achieving this is the work placements that are now available in all our undergraduate courses. And if you are interested in hosting placements in our organization, please talk to me or Maria. We are always happy to help facilitate student placement and engagement. For you international students, it's fantastic to see you here and in such a large number, also for those of you online. We have over 1,100 international students here in our college, and a total student body of over 3,800 students at the university. Not so long ago, I was in your shoes. I mean, not so long ago, a little while ago, when I left France to move to England. You can think, oh, well, at that stage, it was still in Europe, and so it will be like just going next door. But my English was very bad. And I remember a lot of instances where I will be sitting, traditionally at the pub on a Friday afternoon, like everybody does in England, and I couldn't understand a word that was being said. All I was hoping is that when people were laughing, I would laugh, and hopefully they were not laughing at me. But I deeply understand how it is to move to a new country with all its challenges, and also how it is to have to operate on a day-to-day basis in a different language. My adventure from England made me move to Australia with other challenge and much further away from home. I've been here for 16 years, and I understand that being a student, especially in the area you are studying nowadays, can open you doors to travel anywhere and work in so many different fields. I trained in marine biology and oceanography with a specialty in modeling and computer science, which is a very weird combination. And now I'm the director of this training center and work with a lot of partners from defense, the water industry, and health. So welcome today. I hope you will enjoy your morning and all the fantastic speakers that we have with us. Thank you.
Thank you very much, Sophie, for your thoughtful opening address. Thank you. So let us welcome all the speakers here because they are giving up their time to come and speak to you. So let us give them a thunderous applause to welcome them. So it is now my pleasure to introduce Dr. Luigi Baron. He is the CEO of Datum as our next keynote speaker. Luigi is an expert in artificial intelligence, and I know many of you are studying artificial intelligence as part of your course, right? So you all are here, so you will all benefit from his speech. Moreover, he is an author of more than 50 peer-reviewed research papers, which gained 4,500 citations. That is very impressive. And Luigi is also the recipient of numerous awards. So welcome, Luigi, for your presentation. Yeah, thank you.
Excellent. Hi, everyone. My name is Luigi. I'm from Datum, and I'm going to talk about computational optimization. But to get going, so I know it's an early morning, let's get our blood flowing by doing a puzzle. Okay? I like puzzles.
Sorry, just for the live audience, do you mind using them?
I like puzzles. So let's get our brain juices flowing with a puzzle, okay? Let's imagine you're going out for a hike, and you're going out for a hike with 3 colleagues, okay? And you come to a river that you want to cross, and there's this bridge. And you look at this bridge and you immediately ascertain it's rickety, it's very hard to cross, okay? And you know just by looking at it that only 2 people in your party of 4 can cross the bridge at any single time. And because it's dark and the bridge is a bit rickety, you need a torch to cross this bridge. And amongst the 4 of you, you've only got 1 torch, okay? And you're going to get all 4 people across, and you've got to use this single torch. And when you cross, you know that there's only 2 people at a time that can do it. Now, amongst the 4 of you, they all can cross the bridge at different speeds. They're on the screen for you. The fastest, me, I can cross in 1 minute, and the slowest takes 10 minutes to cross, okay? And when you cross in a pair, which it's obvious that you have to do, you have to go at the speed of that slowest person in the pair. So, 4 people on one side, you've got to get them all across the bridge, okay? It should be clear to you that 2 are going to cross, 1's going to come back with the torch, 2's going to cross, 1's going to come back with the torch, and 2 final people are going to cross, and you're done, okay? The question, the puzzle, is what's the minimum time needed to complete that crossing for all 4? Okay, what's the minimum time needed? People are starting to think it through in their heads. How would you solve it as a human? Someone starts offering numbers. Someone says 21 minutes. Can you do better than 21? Yes, people can do better than 21. People quickly get to 19, okay? 19 minutes. And it's pretty obvious why it should be 19 minutes. A, the fastest person, should do all the work. A goes across with B, comes back, A comes across with C, comes back, A crosses with D. Obvious. 19 minutes. Easy puzzle. I wouldn't be standing here if it was that obvious. 19 isn't the best answer. There's in fact a better answer. It's hard for humans to see because this is so blindingly obvious. A does all the work. But indeed, there is a better answer, and that better answer comes about when you realise that the strategy you want to employ is not that A does all the work, but you should be minimising waste. When A and D cross, you're losing a lot of time, okay? So wouldn't it make sense if C and D crosses together? And when you do that, you get this solution. A and B cross, A comes back, C and D cross, B comes back, and A and B do it again. 17 minutes, okay? A much better answer. This puzzle, it's an optimization problem, okay? In real life, humans find the 19-minute answer. Obviously, we'd prefer the 17 answer. Now, that was a really simple puzzle. 4 people on a bridge, okay? Let's think about what happens in real life. Now imagine there are 500 people, and there are multiple bridges, and the bridges are available at different times, and people's speeds depend on who you're walking with. And people can only cross a number of times. They get tired. And they don't like each other, so they don't want to work together. Okay? And then people can come and go at different times. Now that puzzle becomes much more like the real world. And obviously, hopefully, you can see that's a much harder thing to solve. Here's a real world problem, a port. Okay? Just like that puzzle, the problem that we face is something to do with scheduling activities, putting resources to do things, all subject to constraints, and we're trying to achieve some objective. This type of puzzle problem, real-world challenge, happens everywhere. I've just put up some applications there. Dispatch, scheduling, rostering, production, whatever. All over the place. What I'm really talking about here is the area of computational optimization. Finding the best answer to a problem, okay? Not finding the 19, but finding the 17 answer. That's what computational optimization is. Find the best answer to solve a particular problem. New Scientist back in 2012 claimed it is the algorithm that runs the world, and indeed it does. Everyone talks about ChatGPT and all that takeover of AI and stuff. It's this. This stuff controls everything. Your flights, your schedules, your production, what you see, it's all being optimized constantly. Why is it the case? Why do we have this magical classes of algorithms that are doing all these things for us? Well, they're better. They're better than humans, typically 10 to 40% better. They're faster, 5 to 20 times faster, and they're more robust. But why are they really better? Well, humans are lazy. We try one or two things, computers tries millions of things. Humans does what they did yesterday, computers are more systematic, okay? So AI or optimization can do more things more quickly and is quantitative instead of being subjective. Let's talk about a real world problem. Excuse me. This is a case study he did for an in-home care provider. You probably don't know, but around Adelaide, there are lots of sick people in their homes and they need nurses to come and visit them. Happens every day, okay? There are major in-home care providers, NDIS nurses, okay? For this care provider, they do 250,000 visits to people's homes each year. What was remarkable to me in doing that, they travel 2.25 million kilometres. That's people in cars driving between patients' homes, okay? Obviously, they want to do that better. They don't want the 19 answer, they want the 17. When you apply optimization to this, compared to humans, the computer can get significant improvements. 17% reduction in travel distance, but more importantly, a 70% improvement in compliance, making sure the right nurse is at the right patient at the right time. That's good for you, that's good for the sick people, that's good for the environment. The computer schedules these routes much better than what a human can do. Okay, so I've made some claim about the power of optimization or the power of AI. I really want to ram that home just by talking a little bit about one of my favourite topics, games. Okay? Game AI. Right now, as we sit here, every game you can think of, the world champion for that game is a computer. It's not a human, it's a computer. 1951, AI beat tic-tac-toe, 1990, backgammon, and then it's just been a flood. We've all seen Watson play Jeopardy, we've all seen Alberta Poker play poker, and recently we've seen the Dota 2 game fall as well. There are no games in which the best player is a human anymore. So far I've been talking about something about the power of AI. Really what I've been talking about is what's called narrow AI. Something really good at solving a particular problem. If you haven't seen this guy before, this is Atlas from Boston Dynamics. He is, well, See, I amorphitize it already. It is a robot capable of doing some amazing things, okay? And he's showing there in the background. We are constantly pushing the boundaries of that narrowness to try to broaden it, to make it general, okay? What's called artificial general intelligence. Atlas, amazing, and I'm trying to talk a little bit while the video catches up. You can see some of the amazing things that they can do. I'll just let them do their little final hurrah. There it is. Impressive. But maybe you haven't seen Amica. This is Amica. Amica from Engineering Arts takes that concept of Atlas and now puts a human emotion layer on the front of it. Most recently been coupled with ChatGPT, and you can now have intelligent conversations with what looks like a very human response robot. We are getting closer and closer to that AGI that we seek. To finish my talk, I'll say this. Human development, 500,000 years it's taken for us to get to this point. AI is 70 years. 70 years to 500,000. That's what we're achieved at the moment. If you've got any doubt that the AGI or the singularity is coming, I think you haven't experienced time properly. Thank you very much. That's it from me.
Thank you very much, Dr. Luigi
No problem.
Baron, for your insightful keynote, and I hope you learned something about the power of AI. Everyone agree? Yay, very good. Now I invite Susan Salos, our International Student Support Officer, to thank Luigi. Thank you. All right. Our next presenter is Noon McNamara, who is the Director and COO of Circular Energy Group and Maximum Energy. Noon has a wealth of experience. She worked in the role of General Manager in many global companies. So here you go. We are going to listen from Noon. Hopefully it will work.
Good morning.
Yes, let's welcome Noon. Oh, here you go.
For those who speak Bahasa,
Make sure they use the microphone.
I don't think I can follow
The microphone. Otherwise, students live stream external students.
Yeah,
so I apologize. It's not going to be exciting.
Could you please use this because students are watching live stream.
Oh,
Yeah.
sorry. You can hear me now. How do I do that? Right, thank you. Today I'm just going to go through a slightly different than normal. Since I was a graduate, so I thought I'll tell you how I got to where I am today, and then an intro to my company, which is a little bit of very high level energy market and what our company is doing about it and what sort of workforce we have. Right. My first, I'm a mathematician, unfortunately. I did enroll as an electrical engineer, but I had a scholarship, and they said, we actually don't want you to be an engineer, we want you to be a mathematician. So that's what I ended up with. I do have scholarship, so I didn't have to work, so I can afford to do a lot of spending money. University was very kind to me, so I got a tutoring job as part of when I was doing my honors degree. And then at the time also, companies were really looking for employees, so they come to LA University, and I got 3 job offers, and I took State Bank of South Australia, only because they have a better graduate program. I was able to rotate between 6 division of State Bank South Australia, and end up in the state Treasury and International Division. But the bank collapsed with 3.2 billion state debt, and State Treasury then asked me to join them across the road, really, at Victoria Square. So I worked for 2 years at State Treasury, and what I found amazing is they sent me to New Zealand to do a bit of technical work, which is a risk management system for the 3.2 billion state debt. So that's the fun part of my work. And then, because that is a technical degree, for you to actually to get to the top level or management level, you really need some sort of humanity subjects. And I did my MBA with Flinders University, which allowed me to go to Aarhus Business School in Denmark and did 3 subjects. So it's sort of study and fun at the same time. My work, which is National Rail, paid for the entire course, which is about $25,000, and allow me to work and study full-time at the same time. I was actually fortunate because National Rail become Pacific National, become Asiano, so that's a 15 years of work. And what it led me to do is, first thing, they brought me in because I was bored with numbers. State Treasury really is all about derivatives, swaps, and option. And I thought, this is so boring. I really need to do something different that connects me to tangible asset. And someone from National Rail rang me saying, do you need a job? And I said, yes. And I wore my Star Trek badge, went to the interview, and it wasn't an interview. In the end, it was like, oh, Will, what do you think of Captain Kirk? What do you think of the next generation? So an hour later, I got the job. And TMS system, which is a modeling system that look at the entire train network from Adelaide to Perth, Sydney to Perth, Sydney to Brisbane. It makes sure that every train that leaves a terminal is actually profitable. So for me to do that, I actually end up riding a locomotive across the country, talk to train drivers, talk to the union, talk to so many different people. But it made me learn a lot of things about container shipping, train tracks, even though I'm not an electrical engineer. I enjoy it terribly. And the way I use my maths for this project is actually optimization. Thank you for the word, by the way. Optimization for fuel consumption, cost for driver scheduling. So there's quite a lot of maths in a sense here. And then Asiano allow me to go to London, Paris, and Bahrain for work. That is $7 billion tender, which means I need to do a huge financial modeling, because to build a railway terminal, it takes about minimum 9 years, because it takes that long to order the gantry, the rolling stock. So after I finished the $7 billion project, I actually resigned because I was so sick of traveling. You know, people said, it's fantastic, you get to travel around the world, but after a while, you actually miss home. And so I changed my mind. I did a company director's course, and then I decided, since you guys are in Flinders, I better tell you that I did something exciting called Diploma of Festival Event Management, only because I thought, all technical, let's try something different. But I found out that the arts and the theatre do not pay very well, and I do like my money. And okay, I actually was at a barbecue when I found the next job. I have never been to a job interview, so the SCF containers is actually, they built 15,000 shipping containers, and it goes onto trains and trucks. And the company was family owned, and they wanted to make it bigger and grow stronger and then sell, because the owners are all getting a bit old and want to retire. So I actually prepared the back office to make sure they got the right system, the right processes, and the right funding. And I sold that, over $70 million worth. And then I do a quick job for Santos, which are under Centralian control. That's valving automation. And then I went to a global company called Energy Exemplar. This is where I started looking at energy market. So energy simulation software allowed me to actually look at global market as well. And I end up we actually have office in London, Sacramento, and Columbus. And then we opened 7 more in America. But that one, I had to sell the business because the 2 founders got divorced. And well, yeah, long story, but they got divorced. And we sold that to a Californian company. So after all that, I thought, what do I do? And I bumped into a couple of young guys who were setting up a business, but they very technical, but has no business background at all. So I joined Circular Energy Group. And what I want to tell everybody is make sure that you do continuous learning, because you can't just do 1 degree and then that's it. To develop your career, you must keep studying and improving your skills. Anyway, that's me. And in terms of energy market, I could spend 6 hours talking about energy market, but I won't. And this one is just about what businesses suffer today. So if you're a CEO, that's what you're seeing, 1,000 stuff. I mean, Australia is a bit behind when it comes to energy reporting. In Europe, a lot of businesses will actually adopt each other if you don't have the right processes about what you're doing in terms of climate change and sustainable energy commitment. So a lot of business don't have any reporting system at all. They don't actually know what to do. And they just reactive by going, oh, we should get solar and battery and panel, that's it. And I know a business who did that and then left the solar panel and battery for about 3 years. The birds shit on them and nothing happened to it. The other thing is there's not a lot of education about energy, and when you go into an organization, usually you got the engineers, you got the operation teams, you got all the different structure, but none of those guys are expert in energy. So you don't have the resources in a business, and most small to medium businesses can't afford to have someone who knows that. And then when you, as a business owner, you go outside, you suddenly find out that there are 10,000 people who say they're an expert in energy. And this is what you will find outside. There will be an LED company, there will be a solar company, there will be electrician who said, I can do solar, and there's air conditioning you have to worry about, electric vehicle, PPA, that's a couple of financial setup for energy. So it's just so many things. So what we done is we created a company called Circular Energy Group, and our vision is trying to get everyone to understand what to do and help them transition to sustainable energy or net carbon zero. Okay, that's my company. It's a bit complicated. It's getting a bit cleaner, I can assure you. I have 4 businesses, or 4 operation business, and we also supported and endorsed by United Nations, Net Carbon-Free Compact. They advise businesses globally on how to actually transition to net carbon zero. And we also work very closely with Smart Energy Council. So I will be in front of the minister in Queensland to talk about energy policies, or we'll be listening to government policies trying to say, okay, we're going to release EV chargers across the eastern board or something like that. Right, I'll introduce you to each one. There are 4, I apologize for that. Maximum energy. Originally it was maximum lighting. Remember in 2013, nobody cares about solar panel. So it was LED lighting, and we have a 10-year contract with McDonald's Australia. to deliver LED. So if you see that red color lights in McDonald's, that's ours. And some of them are time sensitive. Some of them actually has a little bit of IoT. So they know that you're coming. And we changed our name to Maximum Energy because we started doing a lot more just lighting. And what we really do is design, we do product procurement, project management, we talk to people about what they should be doing, and consulting. Type of project we're recently doing is called embedded generation solar and PV system. Those Mainfreight and boutique, they run large projects. I mean, we're talking about between 20 to $100 million projects. Mainfreight has a lot of warehouses, so every warehouse usually chew up a lot of electricity. So they want to control what they're doing. So we're using BESS. BESS is one of the, I think, popular at the moment. We also do solar system nationally with Macedon Range in New South Wales, Foodland in Balaclava. UPS is common for us. HVAC, which is air conditioning, and then lighting for a lot of stadium and sports places. And our graduate work on all of that, and we do send our graduate to site to look at that. And most of our customers are multi-sites, because once you implement one, it's easy to implement on the others, and a manager doesn't have to go to 7 sites to see what they do, all their solar panel battery doing. It's all monitoring under one site. Maximum Energy takes electrical and renewable engineers. And if you're a graduate with my company, I send you to CEC Solar Battery Design Certification. That's only like 7 days training. We also have a lot of our engineers who got a lot of knowledge in Australian technical and standards. I also hire project and operation managers, and any engineers with Australian grid specification. That's not easy to get, unfortunately. My team is in Adelaide and Sydney for this division. Okay. The next company is Circular Energy Group, Circular Energy, sorry. This is my electricity retail company. We sell electricity to businesses. And in 2022, there were 37 electricity retailers nationally when we first applied. And last year, 11 dropped out because of the energy crisis. They couldn't supply electricity cheap enough for customer, so they bail out. And now the government saying they're not going to issue any certificate, which means our electricity certificate was a lot of money, which I'm going, yay. But we can't sell it because it has to stay with a company that has qualified for 2 years all the certification. So the only way for us to sell it is to sell the company. And I'm not going to do that yet. Why are we different than, say, AGL or what's the other one? Origin. Because we do purely renewable energy sourced from solar panel, wind farm, and biogas. And we do energy matching, load flexibility. We do talk to our customer on the day where they should switch off their farm number 7 or farm number 2. We also do market participation, which means you buy and sell energy from your own battery to another community in the group. That's a typical customer for us. Mango Australia has about 300 members, and they all buy electricity from the community now with each other through our portal. And I take electrical engineers, data and analytics, and anyone with retail energy market background. and there's not many of those around. Again, my team is spread between Adelaide and Melbourne. Right, third company called Sustainable Energy Commitment, or SEC. It's a certified standard that helps businesses prove that they actually have a sustainable energy plan. And this is because there are so many standards around the world and people just got very confused. So on top of that, it is certified and backed by a platform called MAX, which I'll explain in a minute. And that's what a certified standard look like, but you don't see that. It'll be at the back of the process. All you get is that logo on your certificate. So to get a sustainable energy certificate, you have to go through a plan, and you have to submit the plan through the portal. And if you fail, we'll start again. If you pass, then you go to the next level. And what's interesting is we are endorsed by UN, and ACCC and EU has preliminarily approved the trademark. We're working with US at the moment, which is going to be very slow. I can understand it. And it works around the current global energy standard, which is ISO and ESG and ISB. And it can fit for any company, because we're working with small and big company and off-grid companies. And we can actually prove that it's not greenwashing. Sorry, dry mouth. A type of customer that currently working with us is Saputo. They are supplier of cheese and milk to Woolworths. They got 27 warehouses. Last year, it cost them about $1 million in electricity per store, and we dropped it to 25% less than that. Bohill Engineering is an independent company in the middle of nowhere called near Manham. And they got a store, they got basically the whole community is one big family, and we actually manage that for them. Business SA has 3,900 members, and we currently in partnership with Business SA to say that all their members are sustainably practicing the right energy process. This division has slightly different group type of people. We took environmental studies, law and environmental policy, masters or engineering. Now, this division has the most graduate because it's the most recent. I have 2 intern, 2 graduate, and they're all under 30 years old. An intern can be someone in 3rd year or 4th year. You work 2 or 3 days a week with us, you get paid. And a graduate usually has a mentor with that person for at least a year. What else? And that's based in Adelaide. Last one is my technology company called Max Technology. It helps businesses monitor what they're doing in terms of sustainable energy plan. That's what the platform looks like. I'm not going to show you everything out of the screen. That's the front end of the screen for each customer. It's very customized. Then you got your energy usage, energy commitment, there's training, competency. So this is where it covers environmental, social, and governance. And I take computer science depending on their languages. We don't take masters in technology because that's usually more like a project engineer. And we take multimedia just so that the dashboard look a bit better, and electrical and mechanical engineer for data analysis. And all the programmers, unfortunately, is in Melbourne. I'm trying to change that, trying to bring it back to Adelaide. Our technical team are all in Adelaide. Now, on top of that, I sit under the corporate company, which is where HR, legal, marketing. This is not the STEM area. This is more like the boarding operations side. I take accountants, marketing, psychology, tender writer. Yeah, this is like I say. I won't go into this one. It's a bit boring. And that's my company. So if I say you can bribe me with coffee, I'm quite happy with that. I'm based in Tonsley. Now, do I have time to go through this? I get a lot of CV. Sorry, I get a lot of CV from people, and usually sadly there's a lot of spelling errors. There is spell check. I wish they do it. And when you do your application letter, please do not send an application letter that is stock standard, drop from the piece from your Google search, and because I can recognize that. And please put examples of projects that's relevant to what you're asking me to look at. And also, I need to, from your letter, I need to actually understand that you're really passionate about this role that you're asking, not just, hi, I'm applying for a role. And I don't look at a person just from the academic point of view. I actually need you to be fit, and we call it culture fit, which means you have to be able to work with the team. Our team is fast, and they work together. No one do one project by themselves. It's always more than one person. So we do grill you a little bit from technical and normal question. And we work mostly from home, so that not everybody like that apparently. So anyway, that's from me. Thank you.
Yeah, thank you so much, Noon, for your insightful presentation. As you have learned, Noon is based in Tonsley, so just have a coffee with her and try for internship in one of the 4 companies she mentioned. All right, everyone, let's thank Noon. So our next keynote presenter is Ian Dewey, who is a physicist, and he's an oceanographer, which is cool, and he was the former defense scientist. Now the CEO of eSpy Ocean and eSpy Earth. So he's trying to find submarines in satellite images. So he will tell you more. Welcome.
Does this make, yep, loud and noisy. Uh-oh, where's the IT expert? We're trapped. Ah, got no mouse. I can't talk without prompts. This is no good.
It's frozen. The screen is frozen.
One of the Yep, Control Alt Delete. We are going down bad here right now. No, even Control Alt Delete's not working. My apologies. Yep. Anyone got a hammer out there? I've got my hand firmly on the on-off button. I reckon if you stick that into that. Next one along. that into the other end. Woohoo! Whacker.
The clicker should work. The clicker.
Got that. Got that, got that, got that. Woohoo! Ladies and gentlemen, firstly, I am incredibly right-handed, so this might fail. Yes, we are a team who are a satellite image processing group. So I look around the room, I can see a lot of people who potentially will join my opposition or even think you're going to become my opposition. So most of what I'm going to say is lies, or I'm going to focus on the bad bits. Because, hey, no one likes opposition. Is that going to work? Yes. Okay. We have 3 different companies as such. We focus on dark vessel detection. We find the guys who don't want to be found. There's a lot of players in this space. We're specifically after the people who put an awful lot of effort into just not being found. We're not talking the Chinese Navy, we're talking tiny groups. We're also working within pelagic fish schools. Climate change is changing the world of fisheries. The biggest protein used by the world is fish. Being able to get them efficiently is really important. We're playing in that space. We're also looking at terrestrial and agricultural monitoring, because that's what you do when you look at satellites. Every course continually focuses on wine production or whatever. That's just the game. We're looking at methane monitoring. I got up at a talk recently and I mentioned that we were looking at cow farts, and at the end of the whole thing someone pointed out that the methane doesn't come out of that end of the cow. So, yeah, I know, but well, I know it now, but I didn't know it when I was giving the talk. Someone else does all the cow side of things. And we are absolutely committed to education. We actually run an educational website for satellites and for physics, and I speak at the Space School. I should say at this stage, if anything I say is of interest, stalk me on LinkedIn or stalk the company on LinkedIn. Happy to do that. I have to race off during the break, so I'm not going to be around to talk to you, but if I haven't pissed you all off and you don't want to run away from me, come and talk to me. We have a fantastic team, and I'm going to throw something else in here. You're all going to die, so for God's sake, live. There are days when it's perfect, and I ask the team why they're at work. There are days when the weather forecast says it's perfect, and we just shut the office. Live. And most of my life, I'm not going to tell my life story, but it's all been around actually just getting out and doing stuff, having fun. We are in the process of recruiting a super nerd. Our current super nerd has unfortunately moved on. Well, not moved on. The company got bigger than they were, and they were doing us as a hobby job. And we also need a business development person to keep us in line, because the business is growing too quickly. How do we get here? It's an interesting story. The small country of Gabon had a problem. People were coming in and stealing their fish, and it was organised from large governments. Sea Shepherd were contracted to provide boats to help out with that situation, and to carry the armed forces of Gabon on board. The problem was it wasn't big, easy to find fish that were doing the sneaky stuff. They were there, they were making the noise, they were being seen, but then they sent in things that had no radar, no AIS, nothing that could make them easy to find. Sea Shepherd contacted us and said, hey, can we find these impossible to find ships? Being me, I said yes. Silly answer. But I then recruited a whole bunch of people, including Year 11 students, some uni people and so on, and we just said, can we do it? Now, at the time, there was no money, so we had to use readily available satellite image or anything that we could beg, borrow or steal. At the end of the whole process, we ended up with 2 programs. We ended up with a program that could read any satellite image, because we had to, because we just got beg, borrow and steal. But that, when we went commercial, meant that we actually led the world. We look at things like SNAP that those of you in geographical side of things have looked at. Toys. But because we had to, and because I had a fantastic team working on it. The other thing is we had to be able to process that image to find these people who didn't want to be found. So we ended up with a turnkey system that again allowed us to find ships. It also meant we could find cowburps and we could find anything else we wanted to look for in a satellite image. But it was the hard work of creating a great team that got us there. And it's been a team. So we can read any satellite, we can filter max the layers, and our special sauce is that we can pick anything out of it. Well, shouldn't say anything, but if someone asks, I'll say yes, that's what I say. As mentioned right at the beginning by Luigi, if you're not in AI right now, you're not in computing. If you're not using AI layers, whether it's convoluted neural networks or some part of AI right now, you're really not playing in computing. And also, as well as sort of telling you all you're going to die, I'm going to say another really controversial thing. If you're playing with Python full stop, you're not in computing. You need to be good at a range of programs if that's the future you want. I know Python's really good for doing really simple things, but you've got to get beyond that. You've got to work beyond that if you want to work in that industry. Can I go back with this thing? Damn, everything I press goes the wrong way. Ah! How do I go back? Turn it upside down? Quickly want to talk about the two really big bits we're working on right now in biology. One is tuna, one is sharks. We actually need to preserve sharks. If there are no sharks, it's goodbye. It's the same as the bee problem. We need to keep sharks. Stop being scared of them, save them, we need them. Full stop. And we're working in that situation. The problem is that everyone in the geospatial world says we'll use drones to find them. Another controversial thing, there are only two people in the universe who likes drones. It's the person with their hand on the stick, and it's the person who gets the final results. Everyone else hates drones. We actually have multi-million-dollar type contracts because the industry wants to get away from drones. So if you're playing in the geospatial world, think about that. There is not one single person in the universe who wants to lie on a beach suntanning with a drone hovering above them. Unless, of course, they're after fans only or whatever stuff, but just leave it. Work towards satellites and non-invasive systems. Okay, so we ended up in cowburps and weaves. We mentioned that. That's boring and I've run out of time anyway. We are working with defence. We're working with Airbus. We're working with Saab. We're working with a number of other smaller groups within Adelaide. Unseen Labs looking at what we can find out from the wake of ships. A lot of research, a lot of money in that because everyone's trying to hide the boat, but if you move through water you can't hide the wake. So we're playing in that space. Well, that's it. So I'll say goodbye. Stalk me or stalk the company on LinkedIn if you want to know anything more. We are in the process of recruiting. If you're a real programmer, talk to us. If you're really interested in this and if you like sunny days and not working, talk to us. Thank you.
Thank you, Ian, for your great presentation. And again, we have learned about the power of AI, right? So our next presenter is Anish Raj, who is the head of IM&T Enterprise Services at BAE Systems Australia. Anish has been working in the defense industry for the past 15 years and worked for a global IT giant before. And he got his master's in computer applications from India. Okay. So please welcome Anish Raj.
Thank you. Morning, everyone who's physically present here and the people who are digitally present. So this is my first one, right? I've never done one of this before. So when my HR person said, Anish, you are the right candidate, I said yes, because you never argue with the HR team, right? Something for you to remember. I had a chat with our graduate committee team, and then what do I talk about? Because these are master students, and probably they're here to take something away. Maybe they're here for the breakfast. I don't know, because when I was doing my master's, I would probably have come for a free breakfast, right? So what do I talk about? And then they said they had a template. So I've taken the template, moved some things around. I'll talk about the company, what we do as a company. I'll talk a little bit about myself, and then I'll talk a little bit about how you can get into BA if you want to, right? That's assuming technology works, right? So acknowledgement of country, I think we've done it. Couple of people have done it. Welcome everyone. We join you from Ghana country and offer respect and acknowledgement as part of the process of reconciliation and healing to the Ghana people as the traditional owners of this land. We also pay respect to the elders past, present, and emerging. Now, I think I'm going a bit too fast. We're short of time. So BAE, I don't know if you heard about BAE. 70 years in Australia. This is our 70th year. So we're having big celebrations within company to, have that 70th birthday. We play in the sea, air, land, and cybersecurity space. So if you're interested in any of those, that's what we do. I have a video of the company, so I won't be talking too much about BAE. Big company compared to Australian standards, 5,500 people. For every one job, we create 2.3 jobs in the supply chain, meaning procurement or subcontractors, etc., etc. So big influence on the job market. There's a number of sites across Australia. That's the half of the 5,500 people are in Adelaide, but others spread across various geographies. We are a global company, close to 82,000 people across the globe. We have customers in 80 plus countries, right? So big company. Now this is where I hope the video works, and how do I maximize it, because I don't see it here. Sorry?
As a trusted partner to Australia's Defence Force, the role we play in the nation's defence industry is not by chance. When the Air Force, Navy and Army need proven solutions for their future, we are there. And we've been there for almost 70 years, helping the men and women of the Australian Defence Force keep our nation safe, working behind the scenes to deliver the technology that provides a capability edge. But we're not stopping there. We're working to advance Australia, building opportunities for Indigenous businesses, growing our sovereign supply chain, creating exciting career opportunities, and transferring the skills of veterans so they can continue to proudly serve their country. From the Australian outback to our bustling cities, shipyards and hangars, our people are working to ensure the Defence Force has the information and technology it needs. Through autonomy, hypersonics, electronic warfare, aircraft, and maritime sustainment and shipbuilding, we're delivering every minute of every day. We're bringing together the best, and we need to. Hundreds of industry-leading supply chain partners, thousands of highly skilled professionals boldly pushing boundaries to put Australian innovation on the world stage. BAE Systems Australia. All systems go.
So I'm sure I could not have done a better job. So that's why we have the.
Você é good.
Going back to our. Okay, so that was a bit about the company. I hope you are impressed by what we do as a company, if that's what you want to do. Now a little bit about me. So I was born and I grew up in a place called Kerala, which is in the south of India. So there are some images from Kerala, which is an art form of Kerala, tea estates. I don't know if you ever went to the tea estates in Kerala. Very green, a lot of coconut trees. Kerala is also derived from the coconut tree. Then I love traveling. Traveling with friends, with family. I watch movies, do a lot of readings. When I prepared 6 months old, these were some of the books I was reading at that time. Oh, sorry. Thanks, Maria. Yeah, cool. I studied in a military residential school from my year 6 to year 12. What I took out of that school is the friendships that you build when you're young, they last forever, and the power of your alumni network, right? So my school was founded in 1962, and it's 2023, but there's a strong network of alumni over the years across the globe. So get connected with your alumni network. You will, don't underestimate the power an alumni can, hey, I studied in Flinders, can you help me out here? It's a big support for us, for someone who's trying to build a career. So that's what I learned from my school. Did my bachelor's in computer science and master's in computer application. So most of this 3 years bachelor's, 4 years, 3 years master's, a lot of the computer science, information technology, all the topics that we discuss now, that's where I picked that up in those 6 years. Joined, took a job in Bangalore, worked there for 4 years, Oracle Corporation, and then in 2008 moved to Adelaide. I got a job in BA Systems while I was still in Bangalore, so that's how I came over. And that was a big change for, we had just got married at that time. Big change for us. I think the biggest change for me was I had done just enough driving in India to get a license. So came to Adelaide. My company provided 3 weeks of accommodation and a car for 3 weeks. So I think I landed on the Easter day in 2008, and the next day went to the airport to pick up the car. So I had my license. I showed my license and had done driving, but just enough to get the license, right? So they gave me the keys. It was the old Adelaide airport, which without the big hotel buildings and all. So there was just a big car park in front. So I took the keys, went to the car park, sat in the car. Then I had the biggest surprise of my life, because I look down and I tell my wife, something is missing, there's no clutch there, because I had only heard about automatic transmission. I had never seen or driven one. So I wasn't prepared, right? So I said, okay, let's drive around in the car park a little bit, not a very busy car park. Didn't know a lot about roundabouts and rules. So somehow we came out into the main road. This is like 10:30 in the morning. So before going, no Google Maps, or didn't have a smartphone back then. We had the how to get back to the hotel written down on a A4 sheet paper, right? So the first roundabout itself, we get lost, and then I'm screaming at my wife, hey, what's going on? Tell me where to go, left or right? And we kept driving for 4 hours, trying to reach North Adelaide from the airport. Finally saw this Indian restaurant, Beyond India, on the O'Connell Street. So let's stop here, let's have lunch, it's lunchtime. Did a lot of sightseeing that day. Then the staff was, friendly enough to guide us back to the North Adelaide hotel. So that's, be ready for, changes and surprises. It will come at the worst possible time sometimes, right? Then, did my master's, I did an MBA, the company paid for it from AGSM. So what that really helped me is apart from my technology, a strategic view of how business works. So that's really helped me go up in my career. I started as a business analyst in one of the teams. 2-3 years I became a team lead, then I took the role of a solution architect, then an enterprise architect. I became a manager, and then for the last 6 months I had a IMT team, which is information management and technology. It's around 200 people in my team. We look at end user services, which is all the Skype and SharePoint, etc., all those things. Responsible for strategy and architecture, business applications and infrastructure, right? So, like I said, the education that you do over the years, the relations you make, your alumni, all those things did really help me get to where I am now. So just keep those things in mind and make the best out of your current, the uni, etc. Now, getting back to the last part, which is around where do we invest as a company? We do a lot of investment on research and development. So we have a team. In the Tonsley Innovation Center in the Factory of the Future that was mentioned before. I had never been here. I have interviewed, as part of my graduate functional manager role, I have interviewed really smart students from Flinders, but I've never been to this campus. It's really much bigger than what I thought it was. I've always only been to the Tonsley one. We do take a lot of graduates. I think this year we are taking around 120 graduates, and also there's a lot of lot of students who come and work as apprentices across the various business units. And we have a 3-year program. So the graduate program has changed over the years. Initially, we used to have a graduate would come in and they would join a particular team and work there. But then we had a 2-year program where people, students would change. The graduates would change every 6 months. They would go to a different team. Now we have, I think, further refined, and it's a 3-year program. First 2 years, the graduates go around various teams, like a rotation, and then because they've done 2 years within the company, by the end of 2 years, they have a better understanding of what they want to do with their career. So the 3rd year, they spend within one particular team. So then they continue from there. And my understanding is we are very competitive in what we offer to the students as graduates, and the applications normally open in March. I think for this year it's still open. We are still accepting applications based on what I heard from the graduate team. And we recruit across a number of areas. We look at functional roles, we look at internships, graduate programs. So if you see here, we take graduates in engineering, IMNT, which is what I represent, project management, support functions, which is communications, legal, HR. So as from your perspective, probably it's engineering and IMNT, and not sure if some of you would be looking at trades, etc. But we have a very strong graduate program. We have Graduate of the Year awards. There's a strong network. They organize events because when you're a graduate, you come up with a lot of ideas, right? So, and we really appreciate that. We value what the graduates bring to our company. I've had graduates who've come and worked for me, and within 6 to 8 months have done an excellent job, which has gone on to win chairman's awards at the company, right? So we really appreciate the value the graduates bring to us. So we are in Twitter, Facebook, YouTube, LinkedIn. You can look up, apply for the roles, and I'm happy to have a chat. And if I don't have the answer, I can come back and give it to you later. Thank you. Just want to thank Susan and Maria for inviting me here, and the other keynote speakers, because it's a great experience listening to others, and thanks for coming today. Thank you.
Thank you, Anish, for your great presentation. and we are looking forward to collaborate with you. So students, make use of the time to network with Anish because applications are still open. Okay, so let us now have a 10 minutes break. So grab some food and drinks
Have a break.
and make use of the networking. We will have a networking session for half an hour after all the presentations. Yeah.
Yeah, thank you for coming.
Thank you for having me.
Here, why is it showing me this other screen? Because you know things about computers.
Probably, yeah, you got extension on, so that's. See how I'm dragging across like this? So what you want to do is just drag.
This one, because we don't need this one.
Yeah, so you just want to drag that one across
I see.
that way, like that. Yep.
Thank you.
Okay, no problem.
Thank you.
Sophie, you're going.
Thank you for having me.
Thank you.
Yes, that's okay.
See you around.
Yeah, definitely. Good luck with everything.
Some art for fun.
I
today.
know, I know. Yesterday I caught up with the CEO of the Center for Biofilm in England, and they're doing an art competition around fouling.
Yes.
Oh. So you know, good opportunity.
So how are you finding the session so far? Hello, everyone. We need to start the second part of the session. Hi, everyone. All right, let us commence back. So it is now my great pleasure to welcome Dr. Jonathan Hall, who is the co-founder and director and chief scientist of the company called Life Whisperer, which is a leading edge technology for the next keynote. Dr. Jonathan Hall is the winner of so many awards, and his company was more recently named as the top big data company in Australia by Data Magazine UK. And he's an MIT Tech Review Innovator under 35, and is that in Asia Pacific region? Yes, Asia Pacific region, and in daily 40 under 40 entrepreneur. So let us welcome Dr. Jonathan Hall for his next keynote.
Hi, thanks Maria. Hey, my name's Jonathan Hall. I'm really looking forward to talking to you about what we do and also some of the things that I've learned along the way in the journey. It's going to start off mainly as some autobiographical things that I've learned, and then I'll talk a little bit about the company and what we do, which is AI in the healthcare space, which is really cool and interesting. But that's very specific to like who we are as a company, and you're interested in like how you might apply things for your ideas. And so if I talk about my background and the things I've learned, maybe there's some helpful key insights there. So let's get the clicker happening. So this is kind of my background. I did a Bachelor of Science in Adelaide University, Optics and Photonics. Thought that could be useful for defense. I then re-specialized at honors to do mathematical physics, so theoretical physics through and through. I'm very interested in particle physics, and I studied that for 10 years, and I thought I was going to become an academic, but that's not sometimes the way life takes you. You think you're going to go one direction, it takes you in another direction. So after doing a PhD in theoretical physics, working as a postdoctoral researcher, very, very, very academic pathway, that didn't work out, and money runs dry. You have to do something else. I decided to do something a bit different. I went back to retraining, completely different area, in biosensing nanotechnology, still fairly engineering-y focused, which wasn't my background, more theory and mathematics. Going back from that optics degree, going into something that was more specialized towards laser physics, looking at metamaterials and biological matter. And I used my knowledge of electromagnetism and started working towards a second PhD, which I completed under a laureate program. How does that tie in with an industry journey? Things such as engineering tasks, very engineering focused, and I really wanted to do the study that would connect to industry, and I definitely found that after completing, or just as I was completing my PhD in biosensing and nanotechnology. I knew I wanted to break out of the university sector. I had all these industry connections. We thought of an idea that was really awesome, which was actually involved us starting two companies: Life Whisperer, medical grade AI for IVF, so computer vision, looking at embryos in the IVF process, and then also a more general AI healthcare company, Precigen AI. And so, we got some initial support, you can see on the slide there, from the Australian Entrepreneurs Challenge Award. They gave us some awards, and then that really did drive us towards, yes, this is our direction. This is where we're going to go. Entrepreneurship through and through, starting cool businesses with cool, deep technology. So, how do we grow? Where do we start from? Growth can sometimes start from, in my view, like a simple one-liner that really inspires people. The idea that's like, wow, someone who's never heard about cool technology, we can do that? Like, if we can look at an embryo and see if it's healthy with modern technology just through computers and AI, how mega would that be? That was so cool. It inspired people that were outside of science, outside of engineering, and were from a more general marketing or business background that never knew that the universities were producing this kind of technology. It's certainly not usually commercialized. It's very hard to commercialize things out of university because of all of the IP laws and things like that. And so this was a bit of belief. Some early support gets kickstart along the journey, and then sometimes the best idea that you have doesn't take off. have to hold it like a little candle. People will snuff it out and say, well, it's not ready yet. It doesn't work yet. You don't even know how to do it yet. All those things are true. So it can be very demoralizing. But you have to hold on to that faith, that little candle, because of course you haven't done it yet. You haven't started it yet. Once you start, then people will look back and go, oh, I was wrong. You did do it after all at the end. That's too late. You see, it's the beginning bit. How do you start the journey of the growth? So often you get hit by a wave where opportunity meets preparation. You have to be prepared. Core skills, good education, good knowledge of critical thinking. Then the wave will hit you. Then something will then start to happen. So it's that waiting for that wave, getting that early bit of PR, and keeping the consistent message, keeping the PR out there. That is, you're setting out blogs, info about the company. It's people don't want to do it because they don't want to mislead people. I haven't created a cool idea yet. So why am I posting a blog post? Well, it's because you're bringing people along for the journey. You're telling people what you intend to do, and wow, you'll just take that first brave step. It's an exciting story, and it brings people along for the journey with you. And so keeping that consistent message that, well, you've done the first bit, and now you've done this second bit. How awesome is that? Are people going to help? Come on, we're getting it done. It's an important message to know that you need to keep the message going out there, and you're not lying about what you've done. You're saying this is what you hope to do in the future, and keeping the journey going. And so we looked at the IVF sector as our key industry. This is more specific. What was the problem? Well, there's 200 million couples worldwide who have struggling with infertility diseases. That's probably a gross underestimate. And the last call, that is the last thing, after you've tried every other thing, people often go through IVF. It's an extremely painful, degrading, difficult, violent process. People don't talk about how hard it is. And its success rate is about 20% or less. People don't talk about how difficult it is and those hardships, and any improvement to try to help couples going through this difficult process of infertility is going to make a difference. So there was a real need, and we really felt that it was important to focus on this problem to make any improvement in this kind of technology. And so, the idea of growth is that you can have initial wins, but then there are important highs and lows. Once you're up and running, there are many setbacks that demoralize you. Early setbacks can really throw a company or a young person's with an idea and a project and throw it under the bus very quickly. It's terrible. You can have customers walking away, customers who don't really understand what you're trying to do or misunderstand you. Maybe you don't have a customer yet. You're just trying to get a partnership with another organization, and then that goes bad. Something goes wrong and you lose that. Maybe the technology doesn't work to start with. That's a common one. All these things can put people off, but the important thing is persistence and having a mindset that it's okay. You can recover when things are bad. It's normal to have growing pains, and it's sometimes a usual part of the course to have massive setbacks. At Life Whisperer, we actually deleted our entire technology stack a year into our project. We removed all of our IP, deleted all of our AI and data because of an agreement that was very difficult. And so we needed to be sure, and so for legal reasons, we decided to remove everything just to make sure we started again from scratch after a partnership went south. So you see, you can recover from these kinds of things. You can springboard those losses into new wins, especially when you get another partnership, another group who wants to work with you, and then you can recover faster than you think you can by doing that kind of work again. So this is my clever drawing. It might look a little bit like this. This is how it feels. It's the scribble that goes up and down and left and right, and you're going backwards again. You lose everything. What people might see online is sort of a bit of a lie, but it's sort of the story. People will see that you tried. Then they'll see that you did something. They don't know that then you had a panic attack and then stuff was removed and then people fought and then something bad happened. But then they see the next post was you got a new partnership and did a new thing, and then pow, and then you're doing this other thing. Wow. And so you see this building and this journey. But don't get demoralized that it actually feels like this. This is how it really is. So that's okay. This is how the story goes, but it will really feel a little bit like this scribble here. So here's the highs. Yeah, look, how great. You have wonderful opportunities. Steve Wozniak, co-founder of Apple, they honored our company, MIT Tech Review. There's a lot of cool things, brands that will jump on, and they believed in the company and helped drive that to success. But people love to talk about the highs and how great they are, because that helps, puff up stuff and drive forward interest. But the lows are, if anything, more interesting because that's where the pain, that's where you grow, that's what you learn. So here are some examples of important lows. They don't come with cool pictures, unfortunately. But you know, partnerships that fail, losing your intellectual property for some reason, or deciding to, you know, running out of money, or we've run out of money multiple times, and running out of other people's money. Those things are very, very painful and difficult. But it doesn't necessarily kill you. It can, but these things are, you can navigate if you don't panic through many situations that look impossible. Maybe the technology doesn't work for start with. Most new technologies don't work to start with. I mean, who can get one straight out of the box working perfectly? The iPhone didn't work perfectly straight out of the box. Matter of fact, they probably couldn't create an iPhone perfectly out of the box unless they had iterated in market many times. You can't come down from on high with a perfect product. You don't know the customer base yet. You don't know the marketplace yet. So you have to get something out there that sort of barely works and try and get that out and work with people to make it work. That's important. Maybe you get to market a bit too slow. Maybe there's a regulatory event that in a country that topples you. Maybe you get to the market too early. No one knows about this chat GPT. What on earth is that all about? That's too, you know, how do you deal with that? So, you know, other players might be on the market. There can be miscommunication because of competitors. All of these things can go wrong. And it's okay, and you can get through those things step by step. And so it's important you learn. Treat it as a learning exercise step by step. It's important to know that even in internal team issues where you're trying to work out how to manage a team that doesn't work well, streamlining things, all these things are things that you can learn and step through. So, you know, why you might ask, why did we even choose the area of women's health for a start? Like, why looking at that? Now, my personal background, as I said, I'd stepped into this engineering thing to look at embryos and look at, you know, biological cells. But it actually turns out, you know, women's health it's a very important market because it's niche and it's underserved. It's misunderstood and it's generally undervalued. Now, you know, it's not hard to see that there's lots of very particular health issues that really need more of a focus. Pregnancy and infertility are ones that we've been focusing on, and we plan to expand into obstetrics and gynecology. But there's many what's called female incident cancers, that is, cancers that are only on certain, you know, in certain places that are important to understand and need more of a focus. But women are the primary healthcare decision makers in most households by a large margin, and actually do most of the healthcare spending. And so to have that as an underserved market when it's 50% of the world's population just seems sort of crazy. But there's another thing as well, in that the way in which this is sort of a data problem, the data has an access problem. Basically, it happens that a lot of these particular medical services are very distributed and very specific, small boutique clinics. And that means that women's healthcare data is often very sparse, it's distributed, it's often very poor quality in the sense that it's not representative of a whole population. It's just one segment here, one segment there, one segment there. And so it's locked up into small disaggregated specialist clinics, hospitals, on what is called data silos. So you get siloed data, the same way that you would have that in, say, military, where you have many small areas of data that can't talk to each other, and you can't build a unified picture of humanity. That's a big problem, especially when it's distributed over a large geographical region. So we worked on our AI technology to understand this problem and to realize that scalability is a real problem. You don't get data diversity. There's a lot of problems when you try and get the data diversity, and that now you're violating people's ethics if you do it wrong. How do you get around that? You need to protect people's data because data privacy is very important. But then you also need the AI to actually work. So performance is a big issue, and having low quality data or data with wrong records, mistakes, poor quality formatted spreadsheets, that's a real problem. The errors accumulate very fast and they kill AI projects faster than people would like. So you need to have technology that can overcome all those, and we produced that at Precigen by using a new technology that's out there, federated learning, but we made it cost effective, and we've got some patents out on how we do this. We're able to access the knowledge from data sets without owning the data or moving or seeing the data. We turned it on its head. Instead of asking for the data and saying, please put these agreements in place, we said, no, I don't want to see your data. I don't want to see any private data. Let me send the AI to you. It'll learn the clinical knowledge, It will bring the de-identified knowledge back, and then it could synthesize it all together. We had many clinical partnerships in place at this point that they can share the results, but without actually being at risk of sharing personal data. And then the patients get to control their data and benefit from affordable and accessible healthcare products, AI products. So we had projects called AI Open projects. We would collaborate with large groups of hospitals. They would then help us to co-create AI products. We need their knowledge. We need to use their data. We don't want their data. We need the knowledge from their experts. We need the knowledge not just from their experts, but also we need the knowledge that comes from the learnings from their key data. Any clinic that came on board as a data collaborator would benefit from the royalties from the new products that come out, but they could also be a consumer, and you can have a large number of clinics and hospitals that can benefit from those AI products. So what is Life Whisperer? We have a cool software, cloud-based technology, access it in a browser window, and you would drag and drop microscope images to be able to give you knowledge about the likelihood that each embryo would lead to a pregnancy through computer vision and analysis of the morphology. So very wizard, techie kind of stuff, but we're doing more. We were able to expand into genetics knowledge, looking at egg health, looking at the endometrial receptivity. So if you understand all the parts of the process across IVF, you can control that process much better. It can be much more reliable. You can look at the egg health. You can see the likelihood that this will happen. You can see whether the endometrium should be timed right. Valuable embryos that might die on the runway, you can actually time it better, and maybe they can implant them at the right time, get that pregnancy that could never have been done very easily before without many, many failed goes and terrible heartbreak without ever knowing why, and doctors having to turn up to patients, tears in their eyes, to say that it didn't work again, and they have no explanation. So our first two AIs, viability, likelihood of pregnancy, and genetics, the likelihood that it's genetically normal, is instant and non-invasive, which is not the case for many genetics technologies that are quite invasive, requiring dangerous biopsies, cutting, lasering parts of the embryo. So having new technology is an improvement. So we published some papers, we got some cool tech out there, had a globally scalable AI, so we definitely have credible scientific publications here. It's not a flash in the pan, this is like serious research that is done. And we have a large number of groups of clinics and clinical networks in our team with many patients and countries that are contributing to this whole project. And so I want to finish with a great quote I like from The Martian. It's a cool movie, I really like it. Matt Damon's character says, "You just begin, you do the math, you solve one problem, and you solve the next one, and then the next. And if you solve enough problems, you get to come home." Thank you. Thanks.
Thank you, Jonathan, for your fantastic presentation. I can see that you are a real problem solver. And I hope you also learned a life lesson today, right? Perseverance is the key to success. And also you learned from the presentation about the importance of AI, as well as the knowledge coming from learning the big data, right? Thank you. All right, everyone. Our next presenter is Dr. Nina Welty, who is the research manager at CSIRO. And I have a question for you. Anyone from group CSIRO here? No. The group CSIRO, you named your team as CSIRO as part of our topic, right? No one here. Where are they?
Online,
yeah. So students are aware of CSIRO, which is a good thing. And few students asked me, oh, we have learned about AI and technology so far, but we are doing chemistry, no chemists here. So here is the perfect opportunity for you, because Nina is an analytical chemist, and she's also passionate about making tomorrow's world better than today. So let us hear from Nina. Thank you.
Thanks very much for letting me come and chat to you guys. I'd like to begin by acknowledging the Kaurna people as the traditional owners on the lands that we're meeting, and pay my respects to their continuing connection on these lands for their owners past, present, and emerging. So unlike all the other presenters, I don't own my own company. I'm not part of a company, or I'm a for-profit company. I'm part of CSIRO, and I'm here really just to talk about a systems thinking. You know, there's so much opportunity at CSIRO and beyond that it doesn't really matter what you study. It matters how you look at the world and how you're thinking about these problems. And that where you are today, it might feel like, no, you know, what am I going to do with this degree? What job is going to hire me because I've studied this specific thing? It doesn't really matter. So I've got a bit of background of what CSIRO is, for those of you that didn't name your group CSIRO, and then a bit of a personal history of how I landed where I am. So for those of you that don't know, CSIRO is the National Science Agency. We're one of the world's largest multidisciplinary organizations with about 6,000 staff dedicated to working across the range of sciences in 53 sites in Australia and globally. So we have offices in the US, Singapore, Chile, Argentina, and France as well. We host and run and maintain state-of-the-art national research infrastructure. This is just for the public good benefit. And we deliver $10 billion of benefit to the nation last financial year. So the purpose of CSIRO is to solve the greatest challenges through innovation, innovative science, and technology. It's a big purpose. I like to think about it is that we try and make Australia better for everyday Australians. So anything that CSIRO does is about improving the world, making lives better by using science and developing new innovations for it. But it has to be applied, it has to be useful and usable. So the thing that we don't do at CSIRO is research for research's sake. We have some platforms that allow that, but most of our work is really geared at solving problems that industry faces or that people face every day. So we are set up around 6 national challenges. These are health and well-being, food security, quality, securing Australia and the region, resilient, valuable environments, sustainable energy and resources, and future industries. So this is creating new, supporting the new industries. You can find this all on the CSIRO website, but it's just handy, I think, to see kind of the domains the science domains that are needed to solve these challenges. It spans the gamut from analytical chemists to satellites, developing new sensors, new manufacturing tools, nanotechnology, deep time reconstruction, climate forecasting. If you think about it, somebody's doing it in CSIRO, working in the Antarctic, managing giant research vessels, running the telescopes, maintaining the telescopes, finding the screws that fixes the telescopes is also a job. So we run these 6 challenges. We have 4 main objectives. So it's delivering impact through innovation. And so this is turning science into reality, making things real and usable. Because we're using purpose-driven science and technology, and we're trying to earn trust from everyone, from our stakeholders, from the country, by preparing and solving for these great challenges. And one of the great things about CSIRO is it's really committed to engaging and empowering talent. So this is really about ensuring that the people that work here and that work with CSIRO and that are going to work in the world are happy and able to do their best job. And we can't do that if we are working 60 hours a week and have no work-life balance and never see the sunlight. It's really about understanding that we're people. We have hearts, we have emotions, we have dreams and aspirations, and if we can't support that, nothing exciting is going to happen because we're going to get stuck in a panic attack and never come out of it again. And this is, I think, really, really important, and we don't talk about it enough. At least when I was an undergrad, it was never mentioned to me that actually it matters how I am as a person. If I'm not okay, I'm never going to succeed in life. And I would just encourage all of you to, when you're going out and looking for jobs, that you make sure that you feel okay wherever you're going to work. Because a company is going to survive with or without you, but you are way more important than any company or anyone else. And make sure that wherever you're going, that you're going to be taken care of for whatever you want to do in the world. Our other objective is that CSIRO doesn't work in isolation. We're the organization that sits between industry and government, and we only work because we form collaborations. We don't work in isolation. We have to we co-design solutions. We are out there testing, working with organizations and companies and individuals to really make sure that whatever we're doing is usable and useful. So the way CSIRO works is really about its people first. It matters who's there and how you can show up to work and be the best person that you can be. We have bad days and good days, and even on the bad days, it's 100% is however much you can give at the day. So we have a really humane way of working, with regards to our benefits, maternity leave, paternity, family leave, understanding that life happens outside of the office, and that needs to be taken care of first. We work further by working together, so making use of everybody's brains in the room and making sure we have many types of brains and experiences and trajectories coming to find that next solution. We want to make it real, so we want to make sure that we can deliver something that helps and actively changes positively and creates a positive impact. And everything we do is backed by science and evidence, because otherwise we're not going to be trusted. Sometimes CSIRO it's a behemoth organization. It seems slow, but it's because we need to make sure that we have the trust of everybody working with us and relying on CSIRO to be that advisor or that organization between industry and government so that we can make the world better. And it sounds cheesy that I work for an organization that wants to make the world better. This is probably the first place I've ever worked where I feel like that is what we do and we try every day. So we're organized around 10 different business units, ag and food, space, the Australia Centre for Disease Preparedness. This is where all of the COVID vaccines were being tested and developed. Our national collection and marine infrastructure, that's a picture of the RV Investigator that travels around the oceans and to Antarctica. Data 61 is our data science field department. They are the AI, machine learning, anything computer science is there. Our energy, environment, health, biosecurity, manufacturing, and mineral resources. Although data 61 is our data science wing, our computer science scientists live and work in all of these different departments. So we have ML specialists or spatial modelers, satellite technicians, across all of the other domains as well. So who am I? I'm not CSIRO, I'm just Nina. I grew up in the States. I've bumbled around the world, following the question of how we understand what's happening at the small scale in an environment and what that matters for the large scale. So what happens in our soil or in a river or in a peatland? What does that mean for the larger system? So I started working in streams and freshwater rivers in the US. I moved to Finland, where I worked in peatlands, following greenhouse gases, in Siberia, looking at nitrogen feedback loops with regards to global warming, large river restorations in Europe, and mangroves in North Stradbroke Island off the coast of Queensland to understand surface and groundwater interactions and their impact on greenhouse gas cycling. So I was a passionate kid who cared about the environment. I wrote poems about the rainforest when I was 8 years old, weird kid. And I thought, I'm at uni, I can study whatever I want. Let's do environmental science. That's cool. I'm not very good at math. I'm not very good at biology. I'm not very good at chemistry. I'll be an ecologist. I'm now a biogeochemist who does a lot of math, chemistry, and biology. You never know what's going to happen. And just as a fun fact, my friend Erin Hotchkiss is here visiting. She's an associate professor at Virginia Tech of ecology. She and I studied at the same time. We have the same undergrad degree and have vastly different career trajectories. So you just never know where you're going to end up. I got out of the academic stream because I felt that it wasn't serving my purpose. I really wanted to make sure that what I was doing and what I was studying was going to change something and not just be another paper that hopefully somebody reads and applies to policy and thinks about it. I wanted to make sure that what I do is going to have an impact. So I found this job here in Adelaide at CSIRO. Oh, sorry. So this is what my science looks like. So it's understanding the fluxes and transformation of carbon, nitrogen, oxygen, phosphorus as it moves around through the ecosystems. This is how it goes through food webs, how an ecosystem metabolizes these things. It's kind of all chemistry, but it's mediated by microbes and where it is in the environment. And this made use of stable isotopes to understand and partition the different fluxes of nitrogen and carbon as they move through the soil, the plants, and the atmosphere into gases. Stable isotopes are elements, same number of electrons, but different number of neutrons, so one is just heavier. This is cool chemistry. It's fun. You use mass specs. It's working at the atomic scale. You're really understanding the processes and really getting into this nitty-gritty function of an ecosystem. But now, it's same science. I'm working on tools to provide verification of agri-food credentials. So how do you know the apple that you're eating is from Tasmania? By using the apple itself, based on its isotopic and elemental composition. So we've created models, machine learning models and algorithms that understand the spatial distribution and mechanisms of the processes driving these changes at scale so that we can predict a likelihood of occurrence for any product in Australia and their chemical signature, which is really cool. It's a fun idea. I am in the panic attack mode of trying to figure out who cares. A lot of people want to know this, but nobody wants to pay for it. It's nice science, but is it useful is the question that we're 5 years in, we're still trying to figure it out. And this is not going to ever stop, but we are just trying to hold this candle and figure it out. Because of this science area, I'm now a research manager. I'm part of the Ag and Food Impact team, and we are a team of 7 who are responsible for understanding the future changes and priorities and set the direction and strategy of our research priorities. So I am responsible for our portfolio of everything across supply chains in agriculture and food. So this is how a product is grown, processed, manufactured, sold, and to the final consumer. How is this, how do you trust it? How is the system behind this fair and equitable? How do we ensure that we have food and environmental outcomes, safe, healthy, nutritious food without impacting the environment negatively and providing equitable access to those products across the country? This is a great job because I'm responsible for figuring out the big problems and how to solve them and find the teams to do that. So my challenge is to support this paradigm shift in how we think about where and how food is produced. It's not easy. It's a 30-year goal that we have. We increase the value of Australian ag while improving the livelihoods of farmers, lowering food prices, and increasing the choice of customers. This isn't going to be a 5-year research project. This is a 30-year goal for the country. It's a big responsibility, but it's not mine to hold alone. This is a collective national goal, and it's really fun to be trying to figure it out. So how does a biogeochemist fit in the supply chain? It's all systems. So I've gone from thinking about nitrogen cycling and carbon cycling and oxygen and phosphorus to thinking about how soil and turns into food and cycles through the supply chain. Where does it go? How does it end up in the world? And what are the regulations and compliance rules that modify and change the process to which that product flows through? And it's a systems thinking that if you don't remember anything else I say, this is what matters. It's how you can see the world. This is what our supply chain looks like. It's as complicated as the nitrogen cycle, but a lot harder to fix because people are involved. If we're going to change the future, it's going to transform, and I think we're trying to drive it. All of the other panelists are doing this in different ways, and really trying to address this root cause of problems and provide holistic and long-term solutions. You have a panel of brave thinkers in front of you, and I just encourage you to continue and be brave. Think there's no challenge that isn't solvable together. If we can empower stakeholders to reach their outcomes, we are shifting to proactive actions. You know, but who's going to enable this transformation? It's all of us in the room. It's us working together and looking to how we solve these problems from different perspectives and making sure we have that diversity in the room. So I'd like to know, what's the impossible challenge that you want to solve? Thanks.
Thank you, Nina, for your wonderful presentation. And today we learned from Nina's presentation that being yourself is very, very important, and following your passions and building a collaborative network as well. And we learned also that STEM is non-linear, but you can be successful as well. Okay? Thank you. Thank you, Nina. So now let us welcome Peter Francis, who is the founder and managing director of Planworks. And Peter is a respected leader of creative teams, cosmetic laboratories. Again, he's a chemist, right? And also he's the leader of personal care manufacturing plants and corporate divisions. So let us welcome Peter Francis.
Thank you very much. Now, I thought I'd begin by just sharing you a little bit about the cosmetic industry, because it's quite a different industry to what you've been hearing about. But the cosmetic industry, I wanted to first share with you the sort of customers that I serve, because it's a very broad industry. So what I'd like to introduce you to is something unique about my customers, and that is that I primarily work in baby care, children's care, that sort of area. So I'd like to say to you that a baby's skin is like a sponge, and it's not like an adult skin, and it's not like an adult skin for one very important reason. And if I could operate this, it'd be good. That's it. And that is because of the oil production of a human being over their lifetime. If we look at this oil production of a human being over the lifetime, what we understand is that children and babies don't produce oil from their sebaceous glands until they reach puberty. So what happens when they reach puberty is the hormones kick in and they start to develop the hormones that generate sebum. So you wouldn't produce cosmetics that suit an adult and then expect those same ingredients that we use and the same preservatives that we use and the same things we use to be safe to be used on children and babies. So what about our fur babies? So everyone today is probably thinking about pets. I mean, you know, it's interesting that Woolworths just spent $586 million buying pet stock. So Woolworths know something about the Australian population, and that is we love our puppies. You know, so again, what about our fur babies? So interesting enough, as a trichologist, which is my science, is that I spent 30 years studying animal models to try and understand the human model of hair cycling and the hair shaft. And the interesting fact is that now I'm going back over that study work to actually try and understand human studies, to try and understand our pet care, which is an interesting turnaround. So in our pets, they are very similar to us. In fact, that they generate the sebum in their follicles as they start to mature in their life. But there's one very interesting fact that we do in a modern society, is that is after about a year into their life, we desex our pets. And when we desex our pets, what we do is we take away their hormones, and when we take away their hormones, we take away their ability to produce sebum. So again, what happens is we create forever fur babies. So again, my science is coming back to how do we look at the skin of babies to produce safe products for babies, but now it's turning back into how do we look at this for the science of pet care. So we say that fur ain't fur, and so fur ain't hair, and that's because they're slightly different. If we look at the human follicle, we can see that the human follicle grows one hair shaft pretty much out of one hair follicle. When we look at the animal follicle or the pet follicle, we see that there's about 1 to 5 primary hairs and up to 5 to 20 secondary hairs in a follicle. So follicles are not follicles in all mammals. And if we look at the follicles cycling, we can see that in a hair shaft of a human, we've got one hair shaft with a very small follicle, but we look at a fur baby and we can see that the follicle has to accommodate all of this large body of different hair shafts. And so what we're also looking at is that skin is not skin, because in a human we have about 15 layers of cells in our epidermis, but if we're talking about a fur baby, they have about 2 to 3. So the living tissue, the living cells, is much closer to the surface and then much more vulnerable to the cosmetics that we use on our fur babies. So again, fur babies and human babies, again, the thin skin, they're very, very similar. And the more you look at it, the more fascinating it is for me that how similar they actually are. So what I did was I plotted out the 750 follicles per square centimetre of skin that we have on a human head of hair, and a 750 follicles that actually happens to be about the number that they have on a dog's skin as well. So if we look at that and we take the surface area of a human skin, we can see that about 4.8% of that surface area are pores. These are pores going all the way down into the subcutaneous fatty layers without any barrier function. So if we also look at the pets area, we can see that their surface area is 34%. So again, the porosity is at least 7 times greater for our fur babies than it is for our human beings. So these are the areas that get us concerned about the sort of chemicals that we're using. So now you know why your dog is always scratching. So what are they soaking up? Well, if we're using cosmetics on our pets and cosmetics on our kids, they're soaking up everything in our cosmetics, because there is almost no barrier function to the baby's skin or the child's skin or a pet's skin. So also, what are the kids soaking up? Again, what we think about with kids care is we normally think about things that smell like bubble gum and lots of bubbles in the bath. And if you ever had wrinkly fingers and wrinkly toes in the bath, and you think about that and you think, yes, I have, they're always white. They're white wrinkles. And why is that? It's because the blood system shuts down. The vascular system shuts down in those areas of your fingers and your toes because of the penetration delivered from the hydroscopic pressure in the bath water, penetrating unwanted chemicals which are ever in your bath water into the body. So the body's reaction is to create wrinkly fingers and wrinkly toes. So whatever you put into a bath water in solution is able to be penetrated into the skin through either what they call either the follicles or the sweat glands. So it's very serious what we are using on our babies and our fur babies. And what about our mums? Well, of course, being pregnant is a very different time of life, and your tummy is stretching very, very rapidly. But what